All right. Good morning, everybody. It's about 10 o'clock. We're going to get started. Welcome to another long coffee break. I'm Joshua Likes, Senior Sales Engineer out of the Grand Junction office. And today I'm going to have Kevin Ford with us, Solution Sales Manager for Nederman, and he's going to discuss filtration bags versus cartridges. So, Kevin, it's your show, brother.
Hello, everyone. Hope y'all are having a good day. I know it's getting close to the end of the week, so that's always good, right? When Friday rolls around. Again, my name, as Joshua said, my name's Kevin Ford. I'm the Solution Sales Manager. My main job is basically filtration within the Nederman product line, and we're going to start the conversation a little bit. Get into the details. We all know what collectors are, but we want to get into why we look at applications for bag filters versus cartridge filters, and these are some of the things that I want to educate you guys on what we look at. So, um, dust collection and general rules, right? No two applications are the same. No two applications have the exact same solution. Bags and cartridges they do have their specific place in the market. Sometimes, and we're going to get into that. Sometimes people like to crisscross them. Sometimes just because they don't have good bag systems, or they don't have bag systems at all, and or their cartridges kind of don't fit. Their cartridges don't always work as well as their bags. So all bag houses do not perform the same. All cartridge collectors do not perform the same. Again, we're going to get through that in here. Filter media type is as important as the dust collector type itself. The wrong solution may work for a time, but the typically cost it typically costs a lot more to operate and maintain. And that right there is important to say. Like, for instance, when we sell a dust collection system and everybody turns it on from day one, it it always works great because the filter itself isn't full of material, right? So we get, we set up the static pressure for the system to be full of dust, and that may be 4 to 6 inches, but right out of the bat, that the filter, whether there's bag or cartridges, are not full. So everybody thinks everything's working well right out of the gate, and then sometimes we want it to where in 6 months later there's not a problem. We want to talk about things in a year or two. So that's where we look at the applications. So examples, we always talk about, we get the general, hey, I'm working with a flour, or I'm working with food, or I'm getting with plastics or wood. So we're going to, these are some examples of where we need more details on what the dust is. If you look here, wood dust, wood flour, sawdust, wood shavings, wood chips. So if we get a wood dust applications, there's a lot right there in itself that you can get that plays a role into it. Wood flour, people ask, okay, what is wood flour? Well, we do have applications where people are taking the wood product, the dust that's left over, and they'll sometimes hammer mill it. You get some of these pellet plants and things like that. They're taking the dust even to a smaller micron size. Wheat processing, chaff, husk, grain, wheat, meal, and then wheat flour. There in itself, your husk and your grain, that's taking the large product and it's out of the field, and then you're taking it down to whether it's wheat meal or wheat flour. And then all of those have so many different characteristics that we look at. Baking flour, bread flour, um, spices. This is always interesting. The food industry, salt individually, salt, pepper, peppercorn, sugar, and baking soda all have different characteristics. Basil. What makes it even funner is when you have all of those creating like a spice or some type of product that they're adding to, like energy. We're getting a lot of energy drink companies where they're putting powders and stuff like that, and they may be a combination. Right now, I got a project with Takis. I don't know if y'all are familiar. I think everybody's familiar with Takis. Well, they have the different types of spices are a combination. These may be individual, but I get it into where it's a combination. That changes the whole uh, the characteristics of the product itself, because these and spices mainly are dry on the process side of it. But when you put them together and then you're adding it to a flavoring of something, you suddenly will bring moisture into it. So we'll get into that. Metal dust, grinding, cutting. That's a fine particulate metal. We get into add welding in there, but we do lathe with turning, swarf, large tines, things of that nature, saws, and things like that. So we need to be careful about just the simple application name. That's the whole point of this. We need to know a little bit more about the processes that are generating the dust and what the final product looks like and what we're trying to collect. Solutions, similar but different. Indoor installations versus outdoor installations. Combustible dust, we all know, if you haven't, combustible dust has been on everybody's mind a lot more lately just because the rules have changed. So we have that. Hydroscopic dust in outdoor collectors may require insulation, continuous fan operations, heat, and sometimes special temperature readings and non-special. When I talk about hydroscopic dust in those applications, we have to look at it from the idea that when the dust is created, it may be super, super dry, but as soon as some type of moisture, whether it's humidity or process, in some cases, the machinery may create some type of moisture into it. Now that dust that's very, very small while it's dry suddenly will change because it's gotten some moisture to it. So when we talk about hydroscopic dust, that's like that application I told you about with Takis. Um, the spices are opened up, they're poured in. Well, if you've got any type of humidity in there, now the dust in there, the one problems we have with it, it becomes sticky. So we have to figure out how to make sure we put in the right dust collection system, cartridge or filter, to make sure that we don't have our filters filled with dust. So two similar machining lines may have different system requirements due to newer machines create finer dust and older machines than older machines, even if the same make and model. This is becoming more and more prevalent just because technology has advanced so much. We deal with the industries within the wood industry, within the metal industry, plastics industry, and stuff like that. And the machines themselves that may be cutting it into from a large sheet down to whatever they're making, like in wood, to we have the same thing in plastics with your composites and fiberglass. The tooling is getting better. In the past, we may have gotten more curlicues, larger pieces, and stuff like that. Whereas today, the tooling and the machines behind it create more finer dust and less of the larger dust. So we have to look at those conditions as well. Two identical plants. Here's a good scenario to think about. Two identical plants, one near an ocean and one up in the mountains, have different elevation requirements, corrosions issues, and temperature issues, and humidity issues. And me, I'm originally from Houston, Texas, but I deal in Colorado. So we have a lot more drier and a lot more higher elevation in Colorado, and then down there in Houston, I have to deal with the humidity. So again, they're similar, but there's different, and we have to look at characteristics that play into the role of what the right product, whether it's a bag or a cartridge. Each application needs to be treated as a new design, as if it is. Bags versus carts. So here's a list of some of the dust bags and cartridges. Each have their own place in the market. You'll see some over here to the left. You'll see the different ones starting at the top. You've got the large dust. These can be created in every one. Large dust may be where you're taking plastic and you're creating curlicues and chunks and chips and pieces. Bag houses with the large one are more recommended than what you would see with the cartridges, just because cartridges are not made to handle large amounts of dust. And bag filters are. There again lies how's the dust being created and how much dust is being created. Powders, 5 to 20 micron size, high volume applications mostly fit in the bag filters, low to medium quantity, typical. So we're not saying the cartridges can't work on the powders with 5 to 20. Again, it comes to the volume that plays a role into the collector, where it's bag versus cartridges. Smoke and fumes below 5 micron size, we can do them with bags. We do them at a lot slower speeds, but in some cases, you're going to look at a cartridge with that. The cartridge filters work very well with the smaller particulates. Fibrous and agglomerative dust, typically recommended in bags, may in some cases require special bag spacing. we talk about plastics and composites and everything else, and that covers such a wide range just because you have so many different factors. And again, the carbon plants and or plastic plants that I deal with down on the bay, down in the Gulf Coast, have so much different characteristics than what I deal with up in, just like up in Colorado, just because of the climate itself and the humidity. Uh, so uh, cartridges on that for fibrous and agglomerative dust, cartridges are not recommended. Pleat packing becomes a really big issue with that. Basically, and we'll go through that here in a few minutes. The pleats just get full of material, and you just can't clean it. Abrasive dust bags are typically recommended. You get into the abrasive dust and some of the fibrous dust. With the cartridges work well with some of the abrasive dust. You get into sometimes where you have to do uh, pre-separators because sometimes the dust is just too much for either or application. And then we start working on the finer ones. But bag houses work great for the abrasive dust, and in some cases the cartridges as well. Here's that word hydroscopic dust. That one, it depends on both of them. You see bags. It depends on many factors. It really does. Just because moisture can cause so many issues. We get applications where they're trying to break down a product into a fine powder, like at a pharmaceutical plant. As I said earlier, we have to wrap the pipes. They can't there can't be any moisture. It's got to be dry. And there's a temperature regulation through the entire process. And there's, it gets, it handles, it requires a lot of factors that we have to look at, especially if there's moisture at all. Because if you put something in there that can negatively affect the moisture, you're going to have a very unhappy customer. Higher temperatures, bag houses can usually handle the higher temperatures better than the cartridges. The cartridges the media that we with the cartridges just doesn't, they're just not as prevalent. You can customize, as I said, you can customize collector to typically work in most application. But again, why force something if if you spend a little bit money on a larger collector that's going to require less maintenance and less hand holding or maintenance or problems on it, spend a little bit more money and you have and the costs go down over time. Uh, Dan put that in there. Why would you buy a small two-door car? Dan Russo, he's one of our engineers. Why would you buy a small two-door car when your primary purpose is to haul tools and lumbers? And that's a good way of looking at it. So you want to get the right product for the right application. Bag versus cartridge here, large, dry, fibrous, non-hydroscopic dust in a cartridge collector. Dust was fibrous and agglomerative. You see these pleats, it gets packed tight inside there. And you have compressed air. Hopefully it's clean air. Hopefully you've got the right cleaning system get down in there. And it doesn't matter how much you pulse, it's just not cleaning it. You create a higher pressure drop, which affects the overall effectiveness of the dust collector system itself. And if you're sitting there with pulse cleaning it all day long because it's full of dust, then your energy costs are going through the roof. So yes, you may save some money on the front side, but is it costing you more in the long term? And you got short filter life. These filters are going to be full with a heavy dust like that. They're going to be full in 3, 4, 5, 6 months, and then all you're going to do, you may have saved some money on the front side, but you're spending a lot of money replacing the cartridges. Some custom cartridges can solve the problem. Some of the customers, what people say, we hear bag in, bag out. They'll basically turn around and take a cartridge and put a bag around it. Okay, well, it's still got a pulse clean, and trying to get if it's on the bag now, you're trying to pulse clean through a cartridge and a bag. Why not just put a bag house in the first place? Bag houses would never have had this problem with this dust. Cartridge collector, yes, smaller and cheaper, but added cost to solve made this solution more expensive in the long term. Bags are not all the same. Polyester bags are industry standard, but not all the same. Most companies use a polyester felt rigid bag. Nederman uses stretchable fabric super bag, or some people call it a bean bag. Our bags we're looking at have a 3 to 5 year expected lifespan. I do have customers that have had our systems in there, and it's 8 years later, and there's still the bags in there. I don't recommend 8 years, but some people, they're just turning the collector on, right? Air to cloth ratio around 7.7 to 8 to 1. Efficiency rate on our bags are at 3 micron size. Anti-static material woven into the cloth, and we'll show you that here in a minute. So we've got it knocks the static down as well. And if you guys, I mean, if you want a real good visual on this, we get into the foam industry. Foam applications. Just imagine when you cut up the foam that you get when you get a package at home and it's surrounded with that foam, it sticks to everything, the static and things like that. So it's not that hard to create static within the application itself with going through the ductwork in the air. Typically 3 times more than the foot squared on the competition. Lower pressure drop across the filter bags, which allows our system to run. If we've got 10 inches of static, 12 inches of static, 14 inches of static, we're more in that range to where we designed it for at the beginning, even 1, 2, 3 years down the road. Same bags we use on the low end dust collectors and on the high end. More details of the super bag. Again, low pressure drop, elastic characteristics. It does have some flexibility. That's why we call it a bean bag. There is no cage in which you're having to take cages apart to put the bags, to replace the bags. The anti-static fiber is woven into the bags itself, so we're not having to ground anything. And that just the overall long filter life, as much as 20,000 plus hours of runtime. We do have the laboratory test, but that's always available if we need it as well. Cartridges are not all the same. Many factors in how cartridges are designed affect the performance. Large diameter filters per cartridge require more compressed air, compressed air, pulsing and cleaning all day long, just because of the application. Shallow pleat depth cleans easier than the deep pleat. If you understand what I'm talking about, if you've ever had a cartridge filter, you can stick your finger between there. If you stick your finger and half of it's in there, that's usually deep pleat. If you stick it in there and just a part of your fingers into there, that's a shallow pleat. So we look at we build the cartridges as well to handle certain application. Pleat spacing, the wider the pleat space cleans easier, but reduces the filter area. You get into cartridges, you're looking at air to cloth ratio. So depending on what the dust is. So the wider the pleat, that's great, but now do you have to have a bigger collector because you're trying to meet a certain air to cloth ratio for the application. Proper balance of the filter material and spacing is critical based on the dust properties. Large dust requires larger pleats. And a lot of time that's why we don't put it in the larger dust applications. Vertical cartridges versus horizontal cartridges, we do offer both, but the vertical cartridges are known to last a lot longer. The vertical pleats do not re-entrain the dust like the horizontal. If you can imagine, if you've seen the checkerboard ones, and I don't have a picture here, but checkerboard ones, you have one at the top and then 3 more on the bottom. Basically, the top one is just pulse cleaning down onto the next one, and and domino effect from there. On a vertical, they go in. It looks like it's just 4 or 5 cartridges hanging vertically. So when it pulse cleans, it's actually going straight down into the hopper, into the emptying whatever container we're emptying. So you get longer filter life. Many units over pulse wasting compressed air. Again, we go back to that. Everybody's on energy savings. For one, we want to design a cartridge filter around the application is going to work best where it's not pulse cleaning all day long. You get into the details of some of these facilities, they'll tell you that the 2 most expensive items in their plant are compressed air and real estate. So if you make their compressed air line run all day, they're going to be upset with you because it's just because for one, they're losing money there and they're always inside cleaning the collector. Here's the different types of cleaning methods that we have. We have the shaker, reverse air, and then compressed air. We have the shaker units, NFPZs. We use those a lot in schools with wood applications. The duty cycle is intermittent. The dust loading is light to medium. Electricity, cleaning utility is basically electricity because it's a motor. There's really no added installation. The filter pressure is relatively easy to do over with, and the cost of operation is low. Reverse air is basically, those are on our larger collectors, the LBR. Basically, we use a fan to blow the filters down. Our filters are made to keep the dust. The bag filters are made to keep the dust inside of it. So it's mostly continuous when it needs to be. Can handle heavy dust loads. So what we talked about on the fibrous applications, cleaning utilities, electricity, there's no added installation, cost of operation is medium. Your compressed air, obviously it's continuous, depending on, especially on the heavy load. Dust loading is heavy, compressed air, that thing's gonna run all day long. Added installation is most facilities have to add compressor capacity for the dust collector on top of everything that they have in there, and then the lines and everything to run. The filter pressure adds, it does we put about 3 to 6 inches of static pressure on overall system when we lay it out. And the cost of operation is at the highest when the compressed air.
Hey,
Higher.
Kevin, we're gonna have to get towards the end
Yep.
here.
Yep. Nope, we're here. So this one is just normal stuff. So I'm gonna leave it right there for questions. I looked at the timer. So
Awesome. You want to give me the last slide?
yeah. Oh, I'm sorry. Yeah, we are right here.
Awesome. Well, thank you. Obviously, there's a ton of information there that it's hard to fit in for that short of time, and I appreciate you trying to get there, Kevin. Please join us next week with Billy Donovan. He's going to be doing Megacell 2, the new paradigm for HEPA clean room panels with AAF. Thanks for joining us. Have a great weekend. Thank you.